How are you, learners? So in this lesson we're going to be talking about number systems. So we're going to start with one, which is natural numbers. So natural numbers, these are numbers used in the everyday life by the society, and they are used to count physical objects. Take it for example, when we want to count the number of learners in a class, we're going to start by 1. If there are 50 learners in a class, we're going to start on 1, then we go up to 50. So the set of natural numbers is infinite. This means that it does not come to an end, right? Take for example, if you want to count the number of sheep on a farm, we're going to start 1, 2, 3, 4, 5, all the way up to 10. We can go up to 100, we can go up to 1,000, we can go up to 10,000, we can go up to 100,000, 1 million, 1 billion, and trillion, and so on. So the set of natural numbers is infinite. It is said to be infinite because it does not come to an end. So representing that in set notation, we're going to be having n, which represents the set of natural numbers. Is going to be having 1, 2, 3, 4, 5. Then we put those 3 dots, meaning the set is infinite, right? Like it doesn't come up to an end. A very important point to note is that the set of natural numbers starts from 1. When we're counting physical objects, we don't start from 0, but we start from 1, which now takes us to our next number system, which is going to be about whole numbers. Well, so a set of whole numbers now. Natural numbers are whole numbers, but there is now a 0. Remember, natural numbers, the set of natural numbers, it starts from 1. But if it's now the set of whole numbers, it will be starting from 0. So if you take 0 and put it into a set of natural numbers, it becomes a set of whole numbers. So a representation of whole numbers in set notation is going to be W, representing the set of whole numbers. It's going to be starting from 1, 2, 3, 4 up to infinite, right? The set of whole numbers is infinite, just like the set of natural numbers. So basically this sign is just a simplification showing that this set doesn't come to an end. It means that the set is infinite, right? So whenever you see a comma and 3 dots following the set, it means that this set doesn't come to an end, just like here, right? So this means that this set is said to be infinite. Now we go on number system number 4, which is going to be a set of integers. So on integers, if we include negative numbers in a set of whole numbers, it becomes a set of integers, right? So in simple, or in other words, integers are positive and negative whole numbers with 0 included. On the set of whole numbers, if you just include negative numbers, it becomes a set of integers. So representing that in set notation, the integers is represented by the letter Z, right? The capital letter Z. A set of integers is represented by the capital letter Z. That is going to be equal to -3, -2, 0, 1, 2, 3. We kind of left a 1 there. So let me just come and say 1, 2, and 3 up to infinite. The set of integers is infinite as well. It will be coming from negative infinite. It goes from 0, which is the neutral number, then it goes up to positive infinite, right? So this will be +1, +2, and +3, and +4 up to infinite, all the way up to infinite. So let's move on to set number 4. So set number 4 is going to be a set of even numbers. So even numbers, these are numbers exactly divisible by 2, right? They do not leave a remainder when they are divided by 2. Take for example a number like 4. You can divide a number like 4 with 2 without leaving a remainder, right? So if we say 2 into 4, the answer is going to be 2. So 4 is an even number because it is exactly divisible by 2, and when divided by 2, it doesn't leave a remainder. So representing the set of even numbers in set notation, we're going to say E is going to start from 2. The set of even numbers is going to start from 2, right? 4, 6, 8, 10. And remember, integers are also even numbers. So the proper definition of even numbers will be these are integers exactly divisible by 2. So let's just remove the word numbers and just put the word integers, because it is the best correct word to say, right? So these are integers exactly divisible by 2. So minus 16 is also an even number because it is an integer divided by 2. Now we go on set number 5, which is going to be about odd numbers. So odd numbers, these are integers which cannot be divided by 2, right? They always leave a remainder 1 when divided by 2, and they are actually the opposite of even numbers. Remember, an even number is a number which can exactly be divided by 2. So an odd number, it cannot be divided by 2. It is actually the opposite of an even number. So representing that in set notation is going to be O, representing the set of odd numbers starting from 1, 3, 5, 7, 9, 11, 13, and infinite. The set of odd numbers is infinite as well, right? The pattern is that you just skip a number in the middle. So if it's 1, you're going to skip 2, then you go to 3, you skip 4, you go to 5, you skip 1, you go to 7, you skip 8, you go to 9, you skip 10, you go to 11, and all the way up to infinite. So the set number 6 that we want to talk about is about prime numbers. So a prime number, this is an integer which only has 2 factors, right? So the 2 factors will be 1 and itself. Take for example the number 3, right? The number 3. The only factors of 3 is 1 and what? And the 3 itself. So that would be a prime number. Another number can be 7, right? The only factors of 7, that is the numbers that are exactly divided by 7 without leaving a remainder. That would be 1 and 7. So 7 is also a prime number. But if you go to 9, right? 9, it has got a lot of factors, right? The factors are 1, 3, and 9. So this one has got 3 factors. That means it is not a prime number. A prime number only has 2 factors because it can be divided by 1 and that number, which is the prime number. So representing that in set notation, P, which is going to be the set of prime numbers, is going to start from 2, 3, 5, 7, 13, and all the way up to infinite, right? 2 is a prime number because it has only 2 factors, right? The only 2 numbers that can get into 2 without leaving a remainder will be 1 and 2 itself. So 2 is also a prime number, right? So the next number system we're going to talk about is called a rational number. So a rational number, right? A rational number is a number that can be expressed as a fraction where both the numerator and the denominator are integers, right? And the denominator is not 0. The denominator doesn't have to be 0, right? So a representation of a rational number can be integer over natural number, right? It can be 1 over 2 or minus 5 over 7 or 6 over 10 or 10 over 12 or minus 5 over minus 8. That is an example of a rational number. So let me just write that one. The last example of a rational number can be square root of 16 over 9, right? Because we can find the square root of 16 over 9, that is going to be 4 over 3. So in other simpler words, a rational number is an exact number, right? Now let's move on to the last number system, which is going to be about irrational numbers. So an irrational number, these are numbers which are not exact, right? They are the opposite of a rational number. Those irrational numbers, they have square roots which are not exact. For example, the square root of 2. it's not exact, right? So those irrational numbers which have the square roots of which are not exact are called says, which we're going to do later on in the videos, right? If we express the digits of a rational number, of an irrational number, so let me just adjust it to irrational number, they go further without repeating. Take it for example, if we express the square root of 2, you punch on a calculator the square root of 2, the answer is going to be 1,4,142, and they keep on going, right? They keep on going without repeating. When I mean repeating, I mean something like, if you punch on a calculator and you get 4.21212121, or if you punch or express 1/3 on a calculator, it would be 0.333333. So that is what I mean when I say repeating. So these irrational numbers, the numbers, they don't repeat, so they are called irrational numbers, right? So lastly, real numbers. These numbers include all the numbers on a number line. I'm talking about the odd numbers, I'm talking about the natural numbers, I'm talking about the rational numbers, the irrational numbers. So all the numbers that we have done are called real numbers. So this is now the end of the lesson, and till we meet again.